Inside every engine built before 1995, there was a small steel valve about the size of your thumb. It pressed or clipped into a rubber grommet in the valve cover. It cost $5. You replaced it every 30,000 miles in 15 minutes with your bare hands. Engines lasted 300,000 miles, 400,000 miles, sometimes more. That valve is gone now. What replaced it is molded plastic buried inside the valve cover itself, surrounded by coil packs, coolant lines, and heat. It costs $2 to manufacture. The valve cover assembly that it is molded into costs $450 to replace. And it fails, on schedule, somewhere between 80,000 and 120,000 miles. When it does, the repair bill starts at $800 and goes up to $8,000. Today, we are showing you exactly what that valve does, why the old one lasted forever, why the new one does not, how to check yours right now, and what you can do about it before it kills your engine. The valve is called the positive crankcase ventilation valve, commonly called the PCV valve. Every gasoline engine produces blow-by, combustion gases that slip past the piston rings during the power stroke and pressurize the crankcase. If that pressure builds with nowhere to go, it forces oil past gaskets and seals. It mixes with oil vapor and condenses into sludge. It destroys bearings. The PCV valve acts as the pressure relief. It pulls those blow-by gases out of the crankcase and routes them back to the intake manifold where the engine burns them again. No crankcase pressure buildup, no sludge, no gasket failures. Clean oil. Long engine life. One $5 steel valve doing its job every 30,000 miles for the entire life of the engine. The original design was a steel housing with a spring-loaded poppet valve inside. At idle, when manifold vacuum is high, the valve partially restricts flow to regulate how much blow-by gas is pulled into the intake. Underload. As vacuum drops, the valve opens further to handle the increased volume of blow-by gases the engine produces. The spring and the poppet were calibrated to the specific vacuum range of that engine. They were made of steel and rubber because those materials do not degrade from oil vapor exposure at operating temperatures. Motorcraft produced direct-fit PCV valves for Ford trucks and passenger cars through the 1980s and into the mid-90s, using their EV series designations, valves that lasted the life of the engine if you replaced them on schedule. $5, 15 minutes. Done. Here is what changed, and here is why it matters to you right now. Starting in the mid-1990s and accelerating sharply after 2004, manufacturers began integrating the PCV function directly into the valve cover. Instead of a separate bolt-in valve with a steel housing and a calibrated spring, the function was handled by a plastic orifice, a fixed diameter hole molded into the valve cover plastic, with a rubber diaphragm acting as the check valve. The part itself costs roughly $2 to produce, but it is not sold separately. It cannot be replaced separately. It is the valve cover. To replace it, you pull the entire valve cover assembly, including the gasket, coil packs, ignition wiring, and sometimes intake components, and install a complete new cover at $450 for the part alone, before labor. Why did manufacturers make this change? Two reasons, and neither one is about making your engine last longer. First, eliminating the separate PCV assembly saved approximately 40 seconds of assembly line labor per engine and removed two components, the valve and the rubber grommet it seated into, from the parts count. That saved $1.50 per unit in production. Second, EPA Tier 2 emissions rules began phasing in from 2001 and accelerated through 2004, requiring tighter hydrocarbon limits from crankcase ventilation systems. Fixed plastic orifices with no variable flow met those targets more reliably than the spring-loaded valves, which could fluctuate. The regulation was written to reduce emissions. The manufacturers used it to justify eliminating a serviceable part, and replacing it with a sealed assembly that requires a shop visit when it fails. Now here is how the failure actually happens. And here is how to check whether you are already in the failure window. The plastic orifice and the rubber diaphragm in your modern integrated PCV system are operating in one of the most hostile environments in the engine. Blow-by gases contain oil vapor, combustion byproducts, and carbon particles. The temperature cycles from cold start to full operating temperature, roughly 60 degrees Celsius to 150 degrees Celsius, every single time you drive. Plastic and rubber degrade under that combination of thermal cycling and chemical exposure. The orifice begins to accumulate carbon deposits. The rubber diaphragm begins to harden and crack. At 80,000 miles, you start seeing early symptoms. At 100,000 to 120,000 miles, the component fails. When it fails stuck open, the engine begins pulling oil directly from the crankcase into the intake manifold. You will see blue or white smoke from the exhaust. You will find oil in the throttle body. You will pull spark plugs and find them coated in oil. When it fails, stuck closed or clogged, crankcase pressure builds. That pressure blows the weakest seal in the engine, usually the rear main seal, the valve cover gasket, or the oil pan gasket. You lose oil. If you do not catch it, you lose the engine. Check yours right now. Pull your oil cap off the valve cover with the engine running. Hold a piece of paper or a shop rag over the opening. On a healthy engine with a functioning PCV system, you should feel lights, suction. The crankcase is under slight negative pressure. If you feel air pushing out against your hand, the PCV system is blocked or the diaphragm has failed. That crankcase pressure is already working on your seals and gaskets. Next, pull your oil dipstick and look at the oil on the rag. If it is brown and clean, you have time. If it is gray, milky, or has the consistency of mayonnaise, sludge has already formed in the crankcase. That is not just a PCV problem anymore. That is a bearing problem. Check your throttle body. Pop the intake tube off between the air filter and the throttle body. Look inside the throttle body at the blade. Clean aluminum means the system is working. Oil coating on the blade and inside the bore means oil is being pulled through the intake. The PCV is stuck, open. If you find any of those symptoms, here is the repair path, and here is where it splits based on what you are driving. If you are driving a vehicle made before 2000 with a standalone bolt-in PCV valve, you are lucky. Pull your valve cover. Find the grommet, usually on the side or top of the cover, and connected by a hose to the intake manifold. Pull the hose off. The PCV valve is either clipped into that grommet or pressed into it. Pull it straight out or unscrew it. Shake it. A functioning PCV valve rattles. The spring and poppet inside should move freely. If it does not rattle, it is stuck. Discard it. Take the old valve to the parts counter, match it, and buy the replacement. AC Delco, Motorcraft, and Standard Motor Products all make direct replacements for these applications. You will be spending $4 to $8. You can be back together in 15 minutes. If you are driving a post-2000 vehicle with an integrated PCV system, your path is harder, but not impossible. The first thing to do is identify your specific engine and find out whether an aftermarket solution exists. On some applications, including several Ford 4-liter and 5.4-liter engines, several GM 3.6-liter and 5.3-liter applications, and several Toyota 3.5-liter V6 engines, aftermarket manufacturers have developed standalone replacement orifice inserts or diaphragm kits that can be installed without replacing the full valve cover. Search your year, make, model, and engine size alongside the terms PCV repair kit or PCV diaphragm kit. Dorman produces repair kits for several common applications. The kits cost between $12 and $45, and they require between 1 and 3 hours of work depending on the engine layout. That is a different calculation than $800 to $1,200 at a shop. If no standalone repair kit exists for your application, you are looking at a valve cover replacement. Here is how you approach that job to do it right and avoid a comeback. Step 1. Get the factory torque specification for your valve cover bolts before you touch anything. Valve cover bolts on aluminum heads are typically 8 to 12 Newton meters. Over-torque them, and you crack the cover or crush the gasket. Under-torque them, and you have an oil leak the day you finish. The SBS is not a suggestion. Step 2. Disconnect the battery before you pull any of the ignition coils off the valve cover. The coil connectors on most modern engines are live. You do not want to pull a connector off a live coil pack. Disconnect the negative terminal. Wait 2 minutes, then work. Safety first. Step 3. Label every coil pack connector, every vacuum line, and every wiring harness bracket before you remove anything. Take photos with your phone from 3 angles before you disconnect anything. The layout of the wiring harness above the valve cover on a modern V6 or V8 looks like a wiring closet. It is not intuitive when you are putting it back together. Label everything. Step 4. When you pull the old valve cover, do not pry it. If it is stuck, and it will be, tap it gently with a rubber mallet. Prying warps the mating surface on the head. A warped cover surface means a leaking gasket no matter how much sealant you use. Do not pry. Step 5. Before you install the new cover, clean the mating surface on the cylinder head with a lint-free rag and brake cleaner. Get every bit of old gasket material off. Any contamination under the new gasket creates a leak path. Clean the surface thoroughly. Step 6. Install the new cover with a new gasket. Always a new gasket, never reuse, and torque the bolts in sequence from the center outward to the factory spec. Use a proper torque wrench, not a ratchet by feel. A torque wrench. Torque matters. Step 7. Reconnect all coil pack connectors, vacuum lines, and wiring harness brackets. Reconnect the battery. Start the engine. Let it reach full operating temperature. Shut it off. Let it cool 30 minutes. Then check every sealing surface for oil. You're looking for any weeping at the cover to head interface and at the spark plug tube seals inside the cover. Check every seal. Here is the cost reality laid out plainly. The standalone PCV valve on a pre-2000 application, $4 to $8 in parts, 15 minutes of your time. Shop cost for the same job, $60 to $80 at a shop that charges you labor for something you can do in a parking lot. The integrated PCV system repair on a post-2000 application. With a Dorman kit, $12 to $45 in parts, 1 to 3 hours of your time. Shop costs for the same repair, $400 to $600. The full valve cover replacement with OEM parts, $200 to $450 in parts depending on the application, 3 to 5 hours of your time. Shop cost, $800 to $1,200. Doing nothing. Driving past 120,000 miles with a failed PCV system and losing the engine costs $5,000 to $8,000 for an engine replacement, or the truck goes to auction. The $3 PCV valve kept engines alive for 40 years because it was designed to be replaced 5 minutes every 30,000 miles. The engineers who designed those engines understood that a serviceable component, maintained regularly, outlasts any sealed unit that cannot be touched until it fails catastrophically. That knowledge did not disappear. The business decision to eliminate the serviceable part was made deliberately, and you are carrying the consequence of it in your valve cover right now. There are specific engines where this problem is more severe, and you need to know if yours is on the list. The Ford 5.4-liter 3-valve Triton VE8, found in the F-150 from 2004 through 2010, and in the Expedition and Navigator beginning with the 2005 model year, has a documented PCV failure pattern that feeds oil into the intake and causes carbon buildup on the intake valves simultaneously. If you have a 3-valve 5.4 and you are past 80,000 miles, check your throttle body today. The GM 3.6-liter V6, used in the CTS and SRX beginning in 2004, and in the Traverse, Acadia, and Enclave beginning around 2007 through roughly 2017, has an integrated PCV diaphragm in the cam cover that is known to fail and push oil into the intake. Dorman makes a repair kit for several of these applications. Search for Dorman Part 9, 17064 for the direct fit diaphragm replacement. The Toyota 2GR FE 3.5-liter V6, used in the Avalon beginning with the 2005 model year, the Camry and Sienna beginning with the 2007 model year, and the Highlander beginning with the 2008 model year, uses a PCV diaphragm integrated into the rear valve cover on the bank 2 side, buried between the firewall and the engine. When that diaphragm fails, crankcase pressure pushes oil past the rear main seal before you get a check engine light. The symptom is a small oil leak at the bottom of the bell housing that gets blamed on the rear main seal. The actual cause is the failed PCV system. Replace the PCV diaphragm first before you pull the transmission to do the rear main seal. On the other end of the spectrum, the engines that still use accessible, serviceable, or at minimum separately replaceable PCV components are worth knowing. Most pushrod engines, GM LS series V8s in trucks and performance applications, and the older 5.3-liter iron block trucks use a grommet-mounted PCV valve on the valley cover, or a dedicated port that is accessible without valve cover removal. Older Ford 4.6-liter 2-valve modular V8s, the F-150 and Mustang from the late 90s through the early 2000s, have an accessible PCV valve on the passenger side valve cover that is reachable in 10 minutes. These engines are worth keeping for this reason, among others. The broader principle at work here is this: serviceability is durability. A part you can access, inspect, and replace cheaply every 30,000 miles cannot accumulate enough damage to kill your engine. The moment that part is sealed inside an assembly that requires 8 hours of labor to reach, the maintenance interval becomes 0 because no one does the service, and the failure mode becomes catastrophic by default. The $5 valve was not just cheap, it was accessible. Accessibility was the engineering. When you eliminate accessibility, you do not eliminate maintenance requirements. You just guarantee that the maintenance never happens until the engine is already failing. Pull your oil cap. Do the rag test. Pull your throttle body tube and look at the blade. These 3 checks take 5 minutes and tell you everything you need to know about the state of your PCV system right now. If you are clean, keep changing your oil on schedule, with short intervals, 5,000 miles maximum. 3,000 miles if you're in a high mileage application, because clean oil is the single best thing you can do to extend the life of an integrated PCV diaphragm. Oil sludge is what accelerates the clogging. Sludge comes from extended drain intervals and combustion contamination. Short intervals slow the buildup. They do not stop it, but they buy you time, and they buy you warning. If you find oil in the throttle body, pressure pushing out of the oil cap, or milky contamination on the dipstick, do not drive past this. The crankcase pressure is working on every seal in the engine right now. The repair is manageable at the PCV stage. It is catastrophic at the bearing stage. Every mile you add between diagnosis and repair is a mile of excess pressure loading on your rear main seal, your front crank seal, and your rod bearings. The mechanics who keep old trucks running past 300,000 miles are not doing anything exotic. They are doing the boring jobs, the oil changes, the filter swaps, and the PCV valve replacements on schedule every time with the right parts. The $5 valve that kept engines alive for 40 years is still available for every application that was designed to use one. If your engine is young enough that you have not seen the integrated system fail yet, you will. When you do, you will know exactly what it is, exactly why it happened, and exactly what to do about it. Every inspection checklist, valve cover torque sequence, and application-specific Dorman part number we covered today is compiled in the complete engine maintenance reference linked in the description. What is the highest mileage engine you have kept alive with basic maintenance? Drop it in the comments, and if you have pulled a modern valve cover for a PCV repair, tell us which engine and what you found when you got in there. We read every one.